A relatively short video, this one, for section 9G. We talk about something called parametric differentiation. So you looked at parametric equations in the previous chapter. That was when you had x equals, I don't know, something about t, and y equals something different about t, or 2t, or something like that. So we can differentiate with these as well. And it's really just an extension of the chain rule. So remember that what do I want to do for this one? Well, I suppose it depends what the question is. Let's focus on this part. So most of the time you will need to find dy dx, and the way you're going to go about this is you're going to look, dy is on the top, so dy is on the top, dx is on the bottom, so dx is on the bottom. You're going to do this indirectly. You're going to do it via t, because you will have something else. It might be t, or it might be theta, but you will have some other parameter, some other sort of variable, if you like, a different letter or symbol or something. So you're going to work these ones out and then multiply them together. And in effect, then what you're doing is you're finding dy dx. You can use this as a guide if you want, but personally, I think this is the way to go. Okay, so let's do an example. X in terms of t, y in terms of t. Can you see that if we differentiate with respect to t, we're going to get dx over dt equals 3t squared plus 1. So dx dt is not quite the same. You have dt dx, but if you use the reciprocal, upside down, you will have that part there. How about this? Well, y equals, differentiate the t's. You can tell you want to differentiate the t's, so you're differentiating with respect to t, which is 2t. And that's it. And that's this part here. So you make sure you turn this one upside down and then you multiply them together. That's effectively what that says. So let's have a look. So this is dy over dt. This is dx over dt. Now remember, that means that dt over dx is 1 over 3t squared plus 1. So in effect, you're multiplying this one by this one, which gives you this result. Okay, they wanted a specific gradient when t equals 2, so you just put that number in, and there you go. You found the gradient. Okay, you found the gradient of dy dx. This one here is with theta instead, so you do a similar sort of thing. Dx d theta, dx d theta, dy d theta. Turn this one upside down. Okay, multiplied together and so on. So there's dx d theta. Now they've done it a slightly different way. So that means d theta dx is 1 over 3 cos theta. This one is minus 5. So look, you multiply again. You multiply those results together, you get this one here. Okay, they gave you a specific value. So you put that value in there and you get your answer. Okay, there's a bit more going on in that question. It's a normal of a line, okay? But remember, normal means perpendicular to a tangent. So what I've talked about is how you can actually get a gradient, and then you do minus 1 over that to get the equation of a normal. So that's a pretty good example of an exam question, I would say. So just spend a little bit of time making sure you're happy, because mixing differentiation together with equations of a straight line, yep, that sounds like an exam question to me. Pause the video then and have a quick go at that one there on the board. So dy dx, hopefully you found that by using dx dt and dy dt should give you this result here. Okay, was there anything more going on? Well, they wanted it written with tan 2t. So what would have happened is you would have had sort of a bit of a mismatch, cos t sine t and 2t. Well, the top line there, you can use the double angle rule. Okay, put the minus at the front and look at the top. You actually have 8 sine t cos t. Well, that's not a million miles away from 2 sine t cos t, is it? That's what sine 2t would equal. So what have you done? you've multiplied it by 4. So that must be the same as 4 sine 2t. And you've had to do that so you can do the sine divided by the cos to give you your tan. Otherwise, it's not possible. So there's a really good illustration there of how you need to recognize and use the double angle rules backwards. Okay, that's why it's 5 marks. Find an equation to the tangent at C. So tangent, well, we're talking about getting dy dx, aren't we? We're talking about getting the gradient here and then using an x and a y value to make a straight line. So these are the coordinates. So that's using t to get the coordinates on your straight line. Getting m, well, that's plugging in the t value into your dy dx. Okay, put it all together will give you your straight line. So a short section there in the slides, because really it's an extension of the chain rule, parametric differentiation. And you should be able to do 9G now. Well, you should be able to have a good go at 9G. Over to you.